Hi everyone. In the previous session, we discussed how to create the hobs, right? So now in this today's video, so we are going to see how to dump those hobs which we have created. So before we go to the actual session, so let's go through some design documents, right? So the as I mentioned earlier, the hops are mainly used to transfer or send a data from the one phase to another phase, right? So here you can see the hops are the key architectural mechanism that used to hands off a system information in the early boot, right? So mainly in the hubs, right? So there are mainly two concepts, right? So one is a producer and a consumer, right? So the producer, so we in the during the PI phase, so we are going to create the hops. During the Dixie phase, we are going to consume those hops. Okay, so the hop producer phase provides a simple mechanism to allocate a memory for the data storage during the phase execution, right? So because in the previous session we used to create some hubs in PI phase, and that same data we used to retain in the Dixie phase, right? So ultimately what we are doing, so hubs are nothing but a memory data, right? And as you know, the hops are read only in the Dixie phase. Okay, so now you can go through this design document. I will attach in the description. Okay, so let's go get back to the coding. Okay, so now let's go back to our emulator package. Let's pick any random. Let's pick any random Dixie modules, right? So how we are going to check? So we are going to go through this component section. This is where our all the drivers will be placed, and these are the PI modules, and these are the Dixie modules, right? So this is DSC file. So we need to go back to FDF file. So in the FDF file, so here we have our Dixie modules, right? So before, let's pick any random Dixie module, right? So here we have some HII display engine, and then here our GOP is going to get start. So maybe pick somewhere in this driver, right? So maybe let's pick this SMBIOS Dixie as one of the component. Okay. So here we have our SMBIOS Dixie driver, right? Which is a Dixie module. So we'll go so we will go to its entry point. So this is our entry point. So here we'll go here, and whatever the job it used to do, right? So after this, so maybe let's try to halt the system here, right? So we will add a simply a CPU dead loop, which is an infinite for loop. Okay. So now to print or to dump those hops, we need to know mainly two things, right? We need to know its end of that hop and the beginning of that hop where it is getting started, right? So let's capture that here. It's a EFI underscore hop underscore generic header. Okay. So this we are going to call this as a hop start. Okay. And then we will replicate this because now we are keep on going to increment the hobs, right? So we'll store that initial starting location of that hob in some variable. So that variable is nothing but this hob, and there are multiple hops will be there, right? So we need some index to parse through those hops. So let's see uint and then index. Okay. So now here let's assign the index with a value of 0. So now we need to know where is that starting location of that hub, right? So because the hub can be located in different places, like either it can be sitting in the CBFS, either it can be sitting in our SPY flash, or it might be sitting in our cache based on the producer, right? So wherever the producer is going to allocate. Okay, so let's see hop start is equal to, so now this hop start is a type of this generic header. Okay, so let's typecast it to its generic header. So now there is a predefined API to get the starting address of the hub, right? So this is get hob list. So this will give us the starting location of a hob where it is located. Okay. So now let's store that starting location in this hob variable as well. Okay. Okay. So now we need to pass through the end of this hob, right? Until we find the end of the hob. Okay. So now how we will be knowing which is the end of that hob, right? So there is a variable called EFI hob type, end of hob. Okay. So this will tell whether whether we have reached to the end of the hob or not. Where the starting address of that hob will be FFFF. Okay. So now, so since it's a starting address, so we need a while loop until we reach to a starting address where it will have the all ifs. Okay. So now, while a condition, right? So first we are going to check the type, right? Because this end of hop is nothing but a hop type. Okay. So now to get the hop type, we have the existing preprocessor directives or macros get hop underscore type. Okay. And we are going to pass the hob. Okay. So we are going to pass the hob and it will give us the starting address of the, it is going to give the type of that hob. Okay. So now what exactly it is doing? So it is checking this type. So ultimately the type will be one of these types based on the PS specifications. Okay. So now in this case, we need to check the type whether it is matching with this or not, right? So we will check if the hop type is not equal to end of hob list. Okay. So when it is not the end of hob list, so probably it's a so when it goes to inside this while loop, then it's in a hob list. Okay. So now first we will try to print its type. Okay. So let's see debug underscore info, and then we'll print for now just we will print the types. Okay. So we are going to print the type. So for now, let's see 0x percentage x slash n space, and then we need to print the type, right? So anyhow, this is going to provide us the type. Okay, and then followed by the semicolon. Okay, so now what exactly we are doing? So now we are going to start with this hop start, and we will be keep on checking whether the type is matching until the type is matching with this end list or not. And for now we will be printing this type. Okay. So now this hub needs to be pointed to the next hub, right? Else this will be always goes in the infinite loop. Okay. So now how are we going to increment or how are we going to point to that this hub to the next hub, right? So hob is equal to get next hob, and then we will pass the current hob. Okay. So now what exactly this next hob is doing? So it is just a start plus the length. Yeah, here we have, right? So now the start plus the hob length will give the address to the next hob. Okay. So now we have added the dead loop. Let's simply try to build it. Let's see whether we are printing the required types or not. Okay, I will open the command prompt. I will do EDK setup. Okay, so now we will do build. Okay, so now we will go to build folder, emulator IA32, here IA32, winhost exe. So it's generating. Yeah, it is generated. So now we'll run this. And now we can see the execution is halted here, and we did not see those debug macros which we have added, right? So most probably because it's a Dixie module in the emulator package, those Dixie modules will not be printed by default. We need to enable it. Okay. So now let's search for our SMBIOS Dixie. Here we have, right? So we need to enable these serial libraries for this. So let's copy this one and we will paste this here. We'll build again. Oh, looks like there is an error. Okay. No, build is not happened. Oh, so the serial here I'm specifying null. That's the reason. So let's see. Here we have the actual. Oh, sorry. The error is because I did not added this library class here. Okay, so let's remove these ones. Okay, so now we will build it again. Okay, we did not get any errors now. Okay, so build is completed. So now let's run this WinHost. Now we can see there are multiple hops. We can see there is a type 2, there is a type 4, and then there is a type 3, 6, 7, right? So now these are different hops. So which means we can able to successfully dump the hop types now. Okay, so now each hop is will be having its length, right? So let's try to dump that length. Okay, so before try to dump that length, right? So we need let's try to print the string characters, right? Because just printing that hop type as 1, 2, 3, 4 does not make any sense from the logs perspective, right? So now let's create an API here. Something it's going to return the characters, right? So character 16 star. Okay, and then let's call a function called hop type to string, and then it is going to accept the hop type, right? So 16, and then this is hop type. Okay, so we are going to take the input argument, which is the hop type, and then here we will be having a multiple switch statement. Okay, so in this switch statement, we are going to check for this hop type. Okay, so now for each case. Okay, so now let's do the indentation, right? So now there are different hob, right? So this is the hob types which I mentioned. So I will split screen. So I will do this copy paste here for now. Okay, so whenever I see this, I will return the same string. Okay, so now how many types of hob we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So anyhow, this 13, we are not going to have it. So let's see, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so now let's do one by one. Memory pool, which is a pool of memory where we used to allocate. And this FP2 specifies the firmware volumes, unused or unloaded PI modules, and then FV3. Okay, so now with this API, it's going to return the string, right? So in case of the default, let's try to return an unknown. Okay, so hell unknown. Okay, so now we can call this API at the beginning of this. Okay, so now here type. Let's try to print the type, which is percentage um, A, and then here we will pass this type to this API. Okay, so now this API will print the type. Okay, so now this time along with the type, right? So let's try to print the its length as well. Okay, so debug underscore info, and then I will use %/t length 0x percentage x/n. So now we have this hob, right? So hob followed by the hob length. Okay, so now this hob length is event 16. So 0x percentage x should be well and good. So now I will build it again. Okay, build is successful. Let's try to run this. So now here we can see we got the type, we got the length correctly. So now the type is showing as E. It's maybe because I'm using %A. So let's try to use %S. Okay, it's done. Let's run this. Yep, now we can see we have a type and we have a length. Okay, so now let's go through one by one hob, right? To know its information about each type of hobs. At least in this video, we are not going through the entire all the types. At least we'll go through some. Okay, so now which is the first hob? So here we have this EFI handoff, right? So now in this, let's try to print switch, right? So switch, we are going to switch to a type. Okay, so let's do this and then let's maintain the coding standards, default break. And now whenever we see a hop type as this, right? So now this will be having some bunch of information, right? Because each hop type will have its own data format, which it has stored. Okay. So now, so since it's a handoff, so there is an structure. So that structure is nothing but EFI underscore hob underscore hands off info table. Okay. So now here this is handoff hob. Okay. So let's maintain some coding standards. So let's align this. Okay. So now this handoff hob is equal to, right? So now it's a type of that structure, right? So let's try to typecast to this structure. Okay, so it's an hob. So now this handoff table is having, you can see it is having a version, a boot mode, a memory, top of memory, a bottom of memory, and it has a free top memory and the bottom memory and the end of hob list, right? And the same information will be available from this diagram as well. Okay, so now let's try to print this information. Okay, so now I will copy this, I'll paste this. So now what is the first information we have is a version. So it should be end of version. Okay, so now total we have 1, 2, 3, 4, 5, 6, 7. So end list also we'll try to print 4, 5, 6, 7. So we'll print the boot mode and then we'll print the top of memory and then we'll print the bottom of that memory and then we will print the free top, and then we'll print the bottom free top for bottom free memory, and then we will print the end of hob list. Okay, so now this boot mode is uint32, so 0x percentage x should works fine, and the version is also uint32, so percentage x should works fine. Did this? Yeah. Okay. So now, but if you look at, right, so this top, bottom, right, so these are EFI physical address, and these EFI physical address are uint64. So we will use percentage LX. Okay. So now let's try to build it. So before that, we'll close this console. We'll build again. Okay, it is built. So now we will run this again. Okay, so now we have this different type, right? So now let's scroll above. Yeah. So here we can see we have this type which is a hands off, and it is having a length which is in the hex 38. The version is 9, and the boot mode is 0, and the top memory, bottom memory, and the top and bottom free memory, and where exactly this Handoff published is present, its memory location, it is printing. Okay, so now this is the information which is coming from this handoff. Okay, and then we used to do the memory allocations as well, right? So now let's go back to this. Okay, so next one is memory allocation, right? So this memory allocation is having a structure, right? So EFI underscore hob underscore memory allocation. Okay, and this I will call this as a memory hob, and this here we will check case if it is a memory allocation, then memory allocation is equal to this structure. Okay, and then we'll pass the hob. Okay, so now in this, what is the information we can get it from, right? So it is having its own header, and then it is having the allocate descriptor. Okay, so from this descriptor we can get the information like the base address, a length, and what is the type of that memory which is coming from this types here, right? So we have either it might be an boot service data, or it might be a runtime service data, or it might be an MMIO memory, or it might be a persistent, right? Any type, right? So whatever our our UFS specification allows, right? So that type of memory we will get it from here. Okay, so let's try to print this one by one. Okay, so let's start with the base address and the length. Okay, so now here I will first copy this. I'll print this. Okay, so now it is a allocate descriptor dot a base address. So we'll call this as a memory base address, which is percentage %lx, and then we have the memory length and we have the type. Okay, so type should be even 32 should be works fine. Okay, so now memory length, and then we have the memory type. Okay, so now along with this, this is having a name, right, which is nothing but a GUID. So let's try to print that GUID as well. Okay, so now I will simply call this as a GUID. And the GUID in the EDK2, we can simply pass this percentage G, right? So this percentage G is available only in the EDK2 for now. It based on the framework how they implemented, but our debug library has implemented this percentage G. and here we are going to pass the name. Okay, and here we have to pass the address of that GUID. Okay, so now let's try to build it. Okay, it's building. We'll wait. Okay, so now we will run this emulator winhost.exe, and now here we can see, right? So we have this hands off hob, and then we have this memory allocation, right? So we have this length, we have the base address, and what is the length and what is the type, right? So now here the type specifies as the 4, right? So if you go here, let's see, this is 0, 1, 2, 3, 4. So this 4 is nothing but it's a boot time service data, right? So if you create a memory mapped IO, then it will be showing something like this MMIO. Okay, and then do you, maybe let's see, we will go through another hop type, right? So maybe a GUID extension or maybe a CPU, right? So let's go through this CPU. Okay, so others you can explore, but at least for now we will go through the CPU. Okay, so now let's have another case. Okay, so now the CPU is having its own hop type, right? So that name is EFI underscore hob underscore CPU, and here we will call this as a CPU hob. CPU hob, and then we'll typecast to its structure. Okay, so now let's see what are all the attributes which is present in this CPU hob. Okay, so we have the header, right? And then we have this size of the memory space and the size of the IO space. Okay, so let's try to print this memory and the IO space. Okay, so I will copy this size of the memory, and it is pointing to this one, and then an IO. Okay, so let's see whether this header, right? So this header will ultimately contain this type and the length, right? So the length anyhow we are going to we are already printing here, and the type also we are already printing. Okay, so what else this information contains? So it is having this header, it is having a type, length, yeah. Okay, so now let's close this. Let's run this. Okay, so meanwhile, let's see where this hob is coming from, right? So all the type of the hob data, right? All the structures, you can get it from here. The one which we saw is the CFI hob is here. We have the memory pool, and we have the firmware volume 3. And if I scroll above, firmware volume 2, which is FV2. And then here, if I scroll down, we will be having others. And here we have this capsule, which is another type, right? So we'll be having all the information here. Okay, so now let's run this in host, and here we have this hub, which is the one which we have added. So now we have added the CPU, right? So let's see whether the CPU hub is available or not. Yeah, so here we can see, so we have this EFI hub type CPU, and it is having its memory space and the IO space. Okay, so you can explore the other hop types as well, and then you can go through this document as well. And then yeah, so we'll see how to build this CPU hub, and how to build this memory pool hub, or how to build this firmware volume 3 or firmware volume 2 hubs, etc. in the further videos. That's it for today. Thank you.